Hello everyone, it's my 10th lecture, and in this lecture we will continue discuss about the branch instruction, and it is the last lecture of introduction of instruction set. So next instruction in a branch instruction, it is a call. So it is a similar to the jump instruction, but in jump instruction we can jump any location in a given program, while in call instruction we can jump any location which is not part of the program. It's like a subroutine, where we in subroutine, as we discussed subroutine in interrupt of 8085. So here call, and there is a 16-bit address which is operand, and there as we discussed in jump instruction, there is a two type of instruction, call conditional and call unconditional. There is also unconditional and conditional. The program sequence is transferred to the memory location specified by the 16-bit address given in the operand. That means the program is transferred to a subprogram which address location given in the instruction, and after finishing of this subprogram it will return to the main program and continue to run the main program. Before the transfer of the address of the next instruction, after call, that means the content of the program counter is pushed on the stack. So example, it is a set of two instructions, call and return. So in the end of the subprogram we will write to return, not HLT, it is a return. So here opcode is an unconditional, return unconditionally. The program sequence is transferred from the subroutine to the calling program. The 2 bytes from the top of the stack are copied into the program counter, and the program execution begins at the new address. Example, return. So it is all about call and return instruction, which unconditional call and return instruction, as we discussed in jump. There is also conditional call and return, as we discussed in previous instruction, like jump, like JC, jump if carry. So here CC, call if carry, CNC, call if not carry, CZ, call if Z, CNZ, call if not 0, and so on. Similarly, there is also conditional return, like RC, call if carry, RNC, call if return if no carry, RZ, return if 0, RNZ, return not 0. So we can prepare a same chart as we discussed in previous lectures. So it is all about the branch instruction. The next instruction is the control instruction. There is instruction NOP. NOP means no operation. No operation, there is a no operand, and no operation means there is a no operation. Actually it is a 1 byte instruction, and it is generally used in a daily program. So we will discuss this instruction in daily program. So it consumes only 1 byte, and there is a no operation. And a control instruction HLT, as we already know, utility, the operand none. The CPU finishes execution the current instruction and halts any further instruction. An interrupt or reset is necessary to exit from the halt state. Next instruction is DI, disable interrupt. This interrupt enable flip-flops to reset all the interrupt except the trap are disabled. No flags are affected. This instruction, when we in the previous sessions, like when we discussed about the interrupt, so we discussed the DI and EI. Next is the EI, enable interrupt. The interrupt enable flip-flop is set, all the interrupts are enabled, no flags are affected. This instruction is necessary to re-enable the interrupts except trap. So it is a summary of the data transfer instruction which we discussed. It is all about the instruction. Now next program, write a program to arrange a data in ascending oblique descending order. So it is a very good program where we use a call instruction. Basically it is an example of call instruction. So first we have to study the problem statement. So here it is a problem statement, like let's suppose we have a phone numbers which is stored in a given location, let's suppose, and we have to arrange these number into ascending or descending order according to the requirement. So for the purpose of explanation or clear information, we choose only phone number. You can take a 10 numbers, 20 numbers, 30 numbers, 40 numbers, 60, 70 or maximum from 00 to FF number according to your requirement. We can add more than FF number. We can write a number or a program for this. So these numbers, and we have to arrange above data ascending or descending order in a given location. We have to arrange this data in ascending or descending order and write into this location. So in descending order, first we have to select largest number like F2 and we have to write here. Then after next A4 here, then after 79 in 3052 and after that 52. Basically the computer didn't know about whether it is a greater or largest number. We have to write appropriate instruction in the in an appropriate manner so he can find the largest number and store here. It is very easy to find the largest number and store in this location, because in previous lecture, that means 9th lecture, we discussed about we have to find the largest number in a given data string. So we can easily find, you can easily find the largest number in this section, in this number, and you can store in a given location. But second, after that you have to write the second largest number. You have to skip the first one. So it is a very tough task. First you have to find the largest number and store this location. After that you have to again find the second one. So if you are going to find again this location, the microprocessor always find F2 as a largest number. always. So here F2, 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 F2. So first you have to find the largest number in a data string, and you have to remove this number from this string. Then after you can find the second largest number. So if you are going to find the largest number, when you select the largest one, you have to fill it by 0 0. If you fill the 0 0, then again in the string the largest number becomes A4, and then after you fill the 0 0, then the again largest number becomes 79. If you fill 0 0, then again the largest number becomes 52. So it is the concept of finding the data. So now start the program. It's the main program. So as we know, we have a 4 data, so we are using MVIB. B is a count as a counter, 04H, and LXIS 2050 initialization, LXID 3050, it is also initialization here. Then after, so we have first we initialize the 2050 and initialize 3050. Then after we write the call, actually call 1, meanings we have to write a subprogram. First of all, we have to write a subprogram to find the largest number in a given data string. So here we write a 1. Actually it is not 1, it is a address of this location, basically address of this location. So call 1, that means subroutine 1, we have to go the subroutine 1, and after end of this subprogram, here is a return, so it return the same location. So in subroutine 1, here again we write MVIC 04H. It is a copied program which we have discussed in a previous lecture. MVIC 04 LXIH, we take the first data, MOV move memory content copied into accumulator, DCRC, we decrement the counter, then INXH, next data is copied into the memory, compare M. So the first data and second data compared with compared if the number of number data is accumulator is greater than the memory, then there is no carry, then it transfer to here. And if the content of the memory is greater than the accumulator, then this condition becomes false. So then the content of the memory is copied into the accumulator. Then after DCRC, the counter again decrement by 1, then shift, it is goes to here next low number, and after that, after executing of whole program, sorry, here there is a mistake. In the last, it's not STA, basically sorry for interrupt, basically okay, so J and shift. So after executing subroutine 1, basically it is a program which we have discussed in lecture number 9, find the largest number in a given data string. It is a copied program. So after end of this program, there is some problem. Wait for that. So after end of this subprogram, the accumulator have F2, F2H. So it, and as the instruction RET executed, so it will go to the next location, that means STAXT. So as STAXT executed, then the location of DE is we initialize the DE as a 3050. So the content of accumulator F2 is copied or write into 3050H. Now the content of accumulator remains same, there is no change, and next instruction is call to. Call to means we are going to subroutine number 2. So the accumulator content have F2. So we have to find the location where the F2 is loaded, that means this location. So we have to write another program. So here MVIC 04H LXIH 2050H, we initialize the instruction content of LXIH 2050H, and sorry, this is not a valid instruction. Here LXIH first DCR, then again first we take a first number, that means in a memory it is 79, then DCRC it is decremented by 1. Actually both instructions are wrongly written. So in this shift INX INSH DCR after LXIH there is a compare M, CMPM. So the accumulator already have a F2, and as we write this instruction LXIH, that means in the memory becomes 79H. So compare M. So the accumulator compare with the memory. Here we write JZ. Next instruction is JZ. JZ means jump if 0. It is a very important instruction. It compare with the memory content. Compare the memory content. Compare with the accumulator, and when the result becomes 0, then it go to the next location. Then it will become DCRC. After the DCRC, there is some interruption. Sorry friend, we have to pause. So here again I say that as we go to call to, that means then accumulator we have an accumulator is F2, and that F2 goes to the subroutine 2. So here LXIH, that means the memory content and the memory loaded with the 79, and compare M is compared with 79 JZ. If the accumulator is equal to the M, then the 0 flag will be set, jump F0, then it will transfer to this location. So as we incremented by 1 by 1, as we goes to this location where the content of accumulator equal to the memory, so the stack pointer, or we can say memory location, becomes 20553. As we write is MVIM00H. So after execution of this subroutine, the content of 2053 becomes 00, and in 3050 becomes F2. So it is a call 2 after it return to the main program, that means INXT. So it incremented the DE location, that means DE becomes 3052, and DCRB, here B is 04 and it becomes 03, that means one number is stored in that location, J and Z. If not 0, then again it goes to call 1. Again it search the highest number. If it goes to again search the highest number, so in 2053 location it becomes 00. So now in this case, if it is becomes 00, now after executing of subroutine 1, it is after execution of end of this program, in return instruction, the accumulator have the largest number is A4, and it goes to again it is as TXT. So now 3051 have A4H. Now call 2 here as accumulator A4, it becomes again call 2, and this program, after execution of this program, it find the correct location of A4, that means second location, and it is stored here 00. So after continuous execution of this whole program, in the end it stored the data in descending order in the given location 3050, 3051, 3052 and 3053, and in the previous location, that means 2050, 2051, all the location have 00, 00, 00 and so on. So it is a arrange the data in descending order. So what should we change in this program to write a program in data ascending order? There is a very small change. What we have to write here, J and C to JC here, and MVIM here we have to write MVIM FFH only. There is a two changes only. We have to replace J and C to JC, and we have to replace MVIM 00 to MVIM FFH. So it is a program to arrange the data in ascending order. So after execution of this program, in all the above location, that means this location, we have to write the FFFH, and the give below location, that means 3050, 3051, 3052 and 3053, all the content, the data arranged in the ascending order. So My dear friends, that is all about the arrange the data in ascending or descending order. Hope you understand this programming. If you have any doubt or clarification, please call me my number or just WhatsApp me your doubts. I will surely clear your all doubts. Thank you.